Okay, so this is your minerals lab, and minerals have many physical properties that can help us identify them. So right now what you're looking at is a bottle of diluted hydrochloric acid. We will use that to see if a mineral will react with acid. That'll help us identify it. We're also going to use a common nail. If you've looked at your Mohs hardness scale, you will know how hard a mineral is based on if it scratches with a nail. We'll also use a magnet. Some minerals have magnetic properties, so that'll help us identify them. We'll use a penny. That's also on the Mohs hardness scale. So if it scratches with a penny, it's a hardness of around 3. We'll also use my fingernail. We'll use a porcelain plate. This is a streak plate. Minerals, though they may, to our eye, vary in color, their streak will not vary at all. So minerals are always composed of the same elements, but sometimes another element can get kind of thrown in there, and it'll make the outward appearance of the mineral different, but the streak will always stay the same. We'll use a glass plate, and that's called a scratch plate. That's also going to help us determine how hard the mineral is. If it can scratch the glass, it's a pretty hard mineral. I think you need to check your Mohs hardness scale to see how hard it is. And we're also going to use something called luster. Luster can be metallic or non-metallic. There's also many divisions of it beyond that, but for our purposes, we're just going to use metallic or non-metallic. So if you see the way that the light reflects off of this piece of tape, this is a piece of aluminum tape, and you can see that it has a shine to it that looks like a piece of metal or a shiny coin. That is a metallic luster. Now what we're going to do is start using some of the other mineral properties to help us identify which one is which. So on your mineral data collection table, sample number 1 says that it has a streak that is greenish black. So we're going to need to use our streak plate, and we're going to streak each one of the metallic minerals across the plate. So that was our first streak, our second, and our third. Of those 3 streaks, hopefully you can see on the video that this first one has more of a greenish hue to it. So we're going to go with that one first. Okay, then we need to look at the mineral. What color is it? Color's not always a great way to determine what mineral is. Like I said, again, because the outward appearance could be a little bit different. But our streak is always going to be the same. So we know we've got a streak that's greenish black. We've got a metallic luster. The color, if you can see it, it almost looks like gold. It's kind of a pale brass yellow color. I'm not sure if you can see, but there's a lot of cubic crystals all forming together here. They're little tiny cubes. And hopefully that's enough for you to kind of get an idea of what mineral sample 1 is. Look it up on your mineral information table and document 2 other properties that helped you identify this mineral: the mineral name and a common use. And that's what you'll enter in e-learning. So let's check out sample 2. All right, so we have these 2 metallic minerals left. The mineral data collection table says that it is black. Of those 2 samples, which one looks black? Well, this one looks more like a silver gray, and this one is much darker. So we're going to say that one's the black one. Now, to determine what it is, we have to look at some other properties, right? We can go back to our streak. Now remember, this one was sample 1, which had kind of a greenish streak to it. This one was the next one I drug across. It's pretty gray. It's kind of gray and some almost lead looking. It's a darker gray, but it's still gray. And this one is a very dark black, almost like charcoal. So this one had a very black streak. Inside our mineral information table, if we look at the metallic luster, we've got one that says it's strongly magnetic. And this one is indeed strongly magnetic. So that's a property that we can use. It says it has a hardness of 6. Well, if it has a hardness of 6, then it should be able to scratch the glass plate. And it does. I think you could probably hear it, but I can feel it as well. It scratched the glass plate. So it's pretty hard. Alright, so that was mineral sample 2. Again, you're going to need to document 2 properties other than the property that's given in the data table. 2 properties that help you identify it, the mineral name and a common use. And you can gather all that information from the mineral information table. Okay, well that only leaves us this last metallic one, which is sample 3. Now sample 3 says it's metallic, which we know it is. It has cleavage that is cubic. Cleavage is when a mineral breaks along a plane of weak bonding. So some minerals break along one plane, some break along 2. They can break at different angles. But this one, if you look at it, it's the shape of a cube. So it has our cubic cleavage. Now we've got to determine some other properties that help us identify it. So if we look back to the streaks on the streak plate, this one was where I streaked it here in the center. It's got a gray to a kind of a grayish black streak. It's kind of a light gray color, very shiny. It's very heavy compared to the other ones that are about the same size, and I know you can't feel this, but you'll have to take my word for it. Compared to this one, it is very heavy. So that would mean it has a higher specific gravity. We can also look at the hardness of it. If my fingernail can scratch it, it's probably a 2 or a less. It can't really. But if a penny can scratch it, you know it's less than a 3. And the penny definitely puts a line in it and scratches it. So the hardness is less than a 3. So that's sample number 3. Okay, so now all we have is the non-metallics left. We've got to figure out a way to divide those up and make it simpler. So what we did on the mineral data collection table is divided it up by darker and lighter. So we're going to look at the colors of them and split them up. So this is a sample. I'm going to call that a little bit darker because when I compare it to this sample, this one's much lighter. So I'm going to put this one in the light. There's another sample, pretty light, so I'm going to move that to the light. This one is very dark, it's almost black, so I'm going to move that to the dark. That one again, very light. This one, almost black, so we'll move it to the dark. This one's white, so I would call that light. This one's almost clear, so that would be light. Again, almost clear, so we would move that to the light. This one's almost see-through, So we'll put that at a light. Compared to the other ones that were almost clear and almost see-through and very white, this one's pretty dark, so we'll move it to the dark. And the last sample, that one's as well pretty dark, so we'll move that to the dark. Now let's start with our 5 dark samples. Looking at number 4 on your mineral data collection table, it says it has granular crystals. That one doesn't appear really granular. When you think of granular, you need to think of like grains of sand on a beach. Those are grains. This doesn't have grains in it. It has crystals, but they don't look very granular. So we're going to say that's not it. This one almost has like a needle-like quality. If you can see the little lines, they're almost like needles in it. I don't see any grains in there like grains of sand. This one is very flat. It's like a sheet, like a plastic sheet almost. So there's not grains sticking out in this one either. This one too seems to have like a flat sheet looking surface. I don't see grains. Now when I look at that one, I see some grains in it. It's granular too. So now let's go ahead and try to figure out exactly what this is. So we'll use some of the other properties. Well, let's look at the color. Kind of looks like an olive like you'd put in a cocktail. It's got a green kind of color to it. Looks like it doesn't really have any cleavage, like a fracture kind of look. It's not really got any super flat surfaces. Let's check the hardness on it. Let's see if the penny scratches it. Nope, it scratches the surface right off the penny. So it's harder than a 3. See if a nail scratches it. The nail does scratch it. So check your Mohs hardness table. See what that means. It doesn't feel extremely heavy. If I compare it to these metallic ones that we had before, even though these are about the same size, this is much heavier. So I would say you've got a medium to kind of a light specific gravity. Definitely lighter than a 5. Hopefully that's enough to help you identify sample number 4. Alright, so on your mineral data collection table, sample number 5 says it has needle-like crystals. Well, of our dark ones, we said this one didn't have needle-like crystals. It's actually very thin sheets, so that's not a needle. This one again has a lot of flatness to it, has some cleavage. I don't really see any needle formations in there. Look at this one again. We can see some crystals in it, but I don't see needles. Now this one, you can kind of see the needle-like formations. There are the flat sheets, but within the sheets, you see these lines. Now, let's test it out and see what other properties can help us identify what mineral this is. Let's check out the hardness. Can I scratch it with a penny? Nope, it takes the surface off the penny, so we know it's harder than a 3. Looks like it will scratch with a nail. So check your Mohs hardness table and see what scratching with the nail would do. Has to be pretty darn hard to scratch glass, so let's see if it'll scratch glass. Nope, it just crumbles, turns into a powder. So it will not scratch glass. Let's see what we've got for a streak. It's kind of got like a almost a little army green hue to it. It's kind of blackish though too, but you can see you've got some dark green hue to it as well. And hopefully that is enough to help you figure out what mineral sample 5 is. Alright, moving on to 6. Using our hint from the table helps us quite a bit. We also have a little bit of cleavage going on here, right? We've got a flat surface here, a fairly flat surface here. They're meeting at an angle, almost like a corner. So I would say this is your sample 6. Again, it's kind of got a dark green to a greenish black streak. We've got a couple of angles for cleavage, 2 right angles. It's pretty hard. Let's see if we can scratch it with a nail. We can scratch it with a nail, so check out your Mohs hardness for that. So its color is kind of greenish black. Really doesn't give off much of a streak. We can compare the specific gravity of this sample to one of the samples we've already known. It's very light compared to this. I would say maybe half or less than half of the weight of this one. A sample of similar size. So it has a lower specific gravity, maybe around 3.5. And that's sample number 6. Sample number 7, our hint is it has a hardness of 6 and it contains K on the periodic table. Well, if you know what K is on the periodic table, you can use your mineral information table. That'll give you a real good hint. Let's try and figure out some of the other properties. So let's look at hardness. Well, we know that the hardness of this one was less than 3 because I could scratch it with my fingernail. I did that in the earlier part of the video. I don't get a great scratch on it, but I can get a little bit of scratch. I bet you if I take the penny, it'll scratch right through it. So you know this has a hardness of less than 3. Now this one, I couldn't scratch with my fingernail at all. So let's see if the penny will scratch it. Nope. It took a little bit of the copper right off the penny, so we know it's harder than 3. Looks like the nail might have got a little bit of it. Doesn't want to scratch very easily with the nail though. Let's see what the scratch plate does. Will it scratch the scratch plate? Sure will. Scratch the scratch plate pretty good. So there's your sample 7. Scratches the scratch plate. Let's check out that specific gravity again. Try and find a sample that's a fairly similar size. It's very light compared to one of our metallic ones. So we know that the specific gravity is pretty low. We also know we've got a flat plane this way, another flat plane this way. So you've got some 90-degree angles going on here. Probably two 90-degree angles. If you look at the color, it's kind of a pink salmon color. So hopefully that's enough information for you to get sample number 7. Alright, so this is our last dark sample. So we know that this is sample number 8 then. And we also know, because I've scraped it a few times, I can scrape it with my fingernail a little bit. I can scrape it with a penny real good. So we know the hardness is between a 2 and a 3 on the Mohs hardness scale. We also know that it's flat, like a sheet. All these other edges are jagged, right? So because it's flat like a sheet, that's one directional cleavage. We know that it's brown, kind of. You can see some of the brown, some of the black in there. So it's brown to black. We streaked it already once. Alright, so now we're on to the non-metallic lighter minerals. So our first hint is, for sample number 9, that it's the hardest common mineral, and then it says see Mohs hardness table. So Mohs hardness table should tell you what the hardest common mineral is. So for our properties though, let's take a look. If it's the hardest common mineral, it should easily scratch the glass plate. So we're going to go through the lighter ones and see which one easily scratches the glass plate. That one didn't scratch it. It actually rubbed off the surface of the mineral. That one scratched it, but it didn't scratch it really deep. That one just powdered up. That one just powdered up. That one really didn't leave a scratch, it was more powder. And you can hear that one actually scratched the glass plate. The last sample just flakes apart. So this is our hardest one out of our lighter minerals. So let's start looking at the properties of this. It has a plane here, 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 and here. If you count them, there's one right there too. There's 6 planes and they all come to a point. So that's a good indication of who he is. We can also see that this mineral has been broken before in this area. And it kind of fractures. So when it breaks, it doesn't break in a flat plane of cleavage. It doesn't have cleavage. It's breaking almost like glass. It's not very heavy, so it doesn't have a high specific gravity. I would say that has a pretty low specific gravity, at least below 3. We can streak it, see what it'll streak like. It doesn't give off a streak at all, not even any powder. And it's got a very glassy look to it. You can see that in the reflection in the light. So hopefully that's enough information for you to be able to fill out your mineral data table with 2 properties, the mineral name and a common use. Again, you can get those from the data information table. So let's take a look at the next sample on your data table. It says we have cleavage at 2 right angles. Well, this one doesn't really have cleavage, does it? It's got conchoidal fracture again. So that one's out. We know that because this is flat, it has 1 plane of cleavage, so that one's out. I don't really see a lot of cleavage on this one either, at least not in 2 right angles. So we'll put that one out. This one has a shape that's kind of more like a parallelogram. So we know we don't have 90 degrees there, so that one's out. This one appears to be more cubic, so I'm pretty sure that one's out. This one kind of looks like a parallelogram too, but you can see that it's fractured in some places where it probably is not the best representation of the sample. So let's look at some other properties. So we can look at the color, right? It's kind of a grayish color, a little bit on the white side too. I'd go gray for this. You can check out specific gravity. So it's definitely not as heavy as this. And this one we know was a 7.5. So we know this is much lighter than that. This one was a 6 to a 6.5. It's still much lighter than that. I would say probably less than half. So this is probably a specific gravity of less than 3. Check out the hardness. My fingernail won't do it. It actually rubbed off part of my fingernail. Took off part of the penny. The nail might have got a little nick in it, but not a whole lot there. But it definitely scratches the glass plate a little bit. Can we see a streak? No streak. So hopefully, using that information, you can name the properties, 2 properties, the mineral name, and a common use. Alright, back to our data table. Number 11 says it's non-metallic and lighter. It has a hardness of 2, and it says to see Mohs hardness table. So maybe the table actually gives you the answer. But we still have to have other properties to help identify it. So let's start out. We know if it's got a hardness of 2 that my fingernail is going to scratch it. Well, my fingernail doesn't scratch that one. Doesn't scratch that one. It does scratch that one, so we'll keep that one out. It easily scratches that one. And it pretty easily scratches that one. So we've got 3 of them now. So now we got to look at some other properties. Well, we know we've got a hardness of 2 because it's been given to us. Let's look at specific gravity. These samples are about the same size, and this one is a little bit lighter. So I'm going to move this one off to the side. Well, we can take a look at the visual properties. This one's very flat. There's no needles or crystals that are visible. This one, though, if you can look at it, you can see there's needle-like crystals running through it. So I can see those needle-like crystals. I can look at my information table with a glassy luster or a silky to glassy luster. I know I've got a hardness of 2, a light specific gravity. It's kind of a colorless to white. So I can look at my color and see that. We can check out the streak. definitely got a white streak going there. So using your information table, you should be able to take a look. Look for something that's got some silky fibers. Look for something that has a hardness of about 2, a very low specific gravity, 1 directional cleavage. And that's your sample 11. Sample 12, your hint is it's a clay mineral. Now, if you've ever been around clay before, we've only got 4 samples left, so let's take a look at these and see if we can determine what would be clay. Does that look like clay? It looks more like plastic to me. Does that look like clay? It's kind of shiny, so I'm thinking not so much. That one's very shiny too. And clay would be dull, right? And here we are. That looks like, almost looks like chalk. So let's determine some properties that can help us identify what this is. Well, I could scratch it with my fingernail. Not super easy, but I can get a little scratch on it. The penny scratches it really easy. Makes a whole bunch of powder. So we know it's less than a 3 on the Mohs hardness scale. Pretty light. These 2 samples actually feel about the same. So I would say they have approximately the same specific gravity. You remember this is sample number 9. It's very white in color. Gives off a very white streak. Does not appear to have any cleavage. If you can see kind of like the way it arcs here, that's a conchoidal fracture. It's not, doesn't have any specific cleavage at all. No cleavage. So hopefully that's enough for you to look at your information table and to be able to determine what this mineral is. Again, you're going to need 2 properties, a mineral name and the common use. Alright, so 13. It says it's non-metallic, lighter, and a thin sheet. Well, we know that one's more cubic, so that's not a thin sheet. We see that this one's kind of like a parallelogram. So again, not a thin sheet. So this one is going to be our thin sheet. Now let's look at some properties. We knew I could scratch it with my nail. Not real easily, but it scratches very easily with a penny. So it's between a 2 and a 3 on the hardness. It's very light, but I also don't have anything that's about the same size due to the thickness of it to compare it to. We know that it has a 1-directional cleavage because it breaks in a plane. It's also nearly colorless. You can almost see through it. Well, you can see through it. And if I can get it to streak for you, it has kind of a white, clear streak to it. We can look at the other properties and see that it flakes, again, into sheets very easily, much like another mica we looked at. Has a very silvery sheen to it. And those should be enough properties to help you name this sample 13. Sample 14 says that it's non-metallic, it's lighter. It has cleavage at 3 90-degree angles, which makes it cubic. Okay, so if we look at our mineral information table and we compare these last 2 samples that we have, they both have the same streak, white. Their color is the same, it's colorless to white. We have the difference in angles, which can help us, but our specific gravity is very close, probably hard to tell just by hand. Also, our hardness is very close. So if we look in our other properties, we're going to see that one of them fizzes in a weak hydrochloric acid. Well, we have a weak hydrochloric acid. So let's see if one of these fizzes in the weak hydrochloric acid. The acid's just spreading out. I don't see anything happening there. Now that one is reacting. The acid is reacting, letting off carbon dioxide, so it's bubbling, kind of like a carbonated beverage. So, our hint was that we had cleavage at 3 90-degree angles. The one that's fizzing has 3 at 75 degrees, which would be more like a parallelogram. So this does not taste like salt. This reacts with acid, so I'm going to move this off to the side. So our sample 14 will likely taste like salt. It will have a streak that is white, just like the other one. Oh, it would be a powdery white streak if I didn't have acid on it. You can see that. It's a powdery white streak. It's cubic, so that should be able to help you put down at least 2 properties, a mineral name and a common use for sample 14. Lastly, you have sample 15. And now sample 15 we've looked at already. We've said, okay, it looks like a parallelogram. So we know that its cleavage is in the 75-degree angles. We know that it's colorless to white, kind of tinted color. Streak again is a white. You can kind of see the powder coming off. We know that it fizzes in acid. Again, you'll see the bubbles coming off of this as it reacts. Has a low specific gravity, we already discussed that. And that should be enough to help you get 15 named. Put the properties down in the common use, and you should be all set for your minerals lab.